Chris here. Today I'm going to talk about a classroom activity I did recently with a grade 3-4 class on stream erosion. They were studying both habitats and rocks and minerals, so this one worked particularly well. It was easy to set up, the kids seemed to enjoy it, and I think you guys might too, so let's have a look.
So we started the lesson by going over some basic concepts of erosion. In this case, that a flow of water over particles can sometimes mobilize those particles. In this case, this flow of water over sand is enough to move the sand from one side of the dish to the other. Compare that, for instance, these large rocks. That same flow of water isn't enough to move them. And we then transfer this idea to streams. So a fast-flowing stream, maybe these rocks are the only things that would settle out, but a slower-flowing stream, maybe something that wouldn't move the sand, that would be a place that sand can settle. Another way to look at this is put that in a bottle of water, then look at the rocks. The rocks are settling quite quickly, so this again would be something that would happen in a fast stream, where only these rocks have time to settle out. Compare that to the sand in the bottle. The sand and silt takes a much longer time to settle. So in this case, the sand settles at the bottom in a couple of seconds, but the silt actually doesn't settle within the time frame of this video. If you students have a bit more time on their hands, they can actually go ahead and run this overnight, for instance, and actually get that silt to settle out and start seeing that layered kind of effect where you have the biggest particles on the bottom that settle first, and then the smaller particles on top as they settle out later on. So the main part of this activity is looking at the different particles that would settle out in different types of streams environments. Teacher note, definitely worth putting these in a paper bag so the students can't read ahead, so to speak, and figure out what particles are coming up next. In this case, we started with the smallest particle size, which is organics. For organics, I used just common baking flour, which is available pretty much anywhere. The idea is this is a very small particle. It would take a long time to settle out in a stream environment, therefore only a very low velocity environment like a lake or a very slow wetland would allow for this kind of particle to settle out. And again, giving the students an idea of what kind of material would look like on the bottom of a lake, and then talk about what kind of habitat that makes. So for instance, there are bottom feeders that might filter and eat some of this material. There are very small organisms that can burrow into this because it's a very small material. So looking at the kind of habitat that this very small flour or powder kind of environment that you would find in a lake would make for them. And asking again how this is defining the habitats and what can live here, what kind of plants and animals can live in this type of environment. So once your students have had a chance to play around with the material a bit, see what kind of size it makes and how it feels, we're going to go ahead and put it away. In this case, we're going to put it away in a tall, transparent container. Ultimately, as we work through different bed materials for streams, we're going to hopefully be getting what looks like a sedimentary rock, so different layers of different types of bed materials, telling the story of what the stream has been doing, with the discussion around sedimentary rocks intended as a fun reveal at the end of the class. For now, though, let's move on to our next bed material, which is going to be soil. So in this case, it's just regular potting soil from the local hardware store, and this is something that would settle in a bit of a higher velocity environment. So we moved back from the lake, we're now into a swamp or a marsh environment where the particles are a bit bigger, and this is what's going to be settling out. So again, talking to the students about how this velocity environment in the stream has defined what can settle, and by doing that, what kind of habitat this marsh or this swamp makes. So now this isn't organic material. Is this something that the animals can filter feed on? Is this something animals can dig in? Is this something that animals can use, say, to get through winter, where in places where it freezes, if they can go ahead and burrow into this? What kind of animals are using this, and how are they using this type of bed material, and how that differs from the organic material that we were just looking at. So again, letting the kids play around with this material, get a feel for it, get a feel for the size, and then pouring it into your container, again trying to show this layering effect where you have one layer on top of the other. And again, ultimately you're going to be telling the story of how this stream changed over time based on the bed material that was laid down as the velocity in the stream changed. So now that we've talked about the organics and the soil material, let's talk about the next material up, which is sand. So sand, as we saw early on, is a material that we can move with water. It's a bit of a heavier material than the other two. So now we're looking at a more active stream flow area, something maybe with a sinuous channel and a large overbank. If you're feeling particularly adventurous, you can talk about overbanks, you can talk about floodplains, but the core of this is just to talk about how this is a heavier material and it would take a bit higher flows, a bit higher velocities to go ahead and mobilize this sand. So again, coming back to this as a habitat, talking to the students about what kind of habitat this sand makes. Now that we've got something that, say, animals can burrow in, can they still feed on this? What kind of animals would burrow into this higher velocity environment to kind of take shelter if there was a very high velocity coming down the channel, and how they would use this to make a home for themselves. And again, how the velocity in the stream, how that speed of the water in the stream has defined this bed material. Now, this would be something that's moving a bit faster, that's not allowing those small particles to settle out, and talking about how that really defined the habitat for the things living in this stream. And once the students have had a chance to play around with the material, get a sense for its size and how it moves, go ahead and pour that into our container, and looking again for that layering. Talking to students afterward, the pouring was the most satisfying part of the entire lesson because they enjoyed watching that. So having talked about the smaller particle sizes, now we're moving on to larger particles. In this case, it's gravel. So this is riverstone bought from a local hardware store. I went through and sorted out the smallest kind of rocks I could find in there. And this would be, again, a higher stream flow, a higher velocity environment. So now we've moved from a sinuous river to maybe more of a stream with pools and riffles. And again, talking to the students, what kind of habitat this makes. The velocity is a bit higher. Now things might not be able to burrow into this. Small organisms, small fish wouldn't be able to move this stuff aside with the same ease as they did with the sand and the smaller particles. So how does this make a home for different fish? How does this make a home for different things living in the stream? Do they now have to then hide between the rocks to get away from predators? They have to hide between the rocks if they're trying to get away from a high flow through spring or some other event. So again, the velocity of the stream, the speed of the flow, has defined what the bed material is going to be. And that bed material chooses the habitat. It makes the habitat for the animals living in there. It sets what kind of lifestyle they can lead and what kind of life cycle they can have based on that bed material. And again, ending with your pour. So you're trying to get this into your container to make it look like a sedimentary rock. We've got some organics, some silt, some sand, and now some gravel. And this is starting to look like something they might recognize. And once you've got these rocks in there, we can move on to the last particle size, which is a larger stone. So in this case, I've taken the river stone that I had before and sorted out the largest pieces. And again, not looking for anything exactly large, not something that the students might not be able to pick up, or if they dropped it, it might destroy or damage something, but looking for something that gives them an idea of the size. And these are things that would settle out in a very high velocity environment. So now we're talking about a mountain stream, something that's fairly fast flowing. And again, talking to the students just in general about how this looks or what kind of habitat this makes. So now we're looking at rocks that are fairly large. Do animals hide between these rocks? What kind of animals have to deal with these high flow environments? Can small amphibians, for instance, can slower fish survive in this high flow environment? And how does that affect what's living and using this environment as a habitat? So finally, again, pouring this into your container. And again, we're hopefully seeing the kids recognize this as kind of a sedimentary rock layer. And if they don't, go ahead and prompt them for that a bit. Ask them how they recognize that. And now we've got this container, which is telling the story of the stream. And this is important because streams do actually change over time. So for instance, the climate might change, a beaver might move in and build a dam and change the flow environment. And this record, this sedimentary record, will go to tell you how that stream changed. It's really important, not just for biologists looking to figure out what's living in the stream, but also for engineers if we're rebuilding a stream after some kind of disturbance has occurred and trying to renaturalize it. And it's not even just here on Earth. For instance, there's probes on Mars right now looking at sedimentary rock layers, looking at rock layers that formed in this kind of environment, and this is where we might be finding life off of Earth, is this kind of process, this kind of sedimentary layering. So again, that's the lesson. I hope you guys enjoyed this. Let me know if you did, and thank you very much for watching.